Okay, remember how we talk about how important algebra is? Well, here's another concept that comes from algebra. Here's example 6. I am going to integrate dx over, there's a d, contrary to what it looks like, it's still a d, negative x squared minus 8x minus 7. What is our go-to method for integration? U sub, good. Can I do a U sub here? No, right? No. So, and the reason for that is because I've got a square down here. This would be my U, right? This would be my U for my U sub, but I don't have that additional x up here to U sub out. So here are our defining characteristics. I'm going to say that all chapter long. Defining characteristics. You have a quadratic, and under a radical is helpful, but it doesn't have to be. You just have a quadratic, and you cannot U sub it. So with that quadratic, we are going to take this out and complete the square. Negative x squared minus 8x minus 7. All right? Now, you learned completing, or you should have learned completing the square at least, if you took pre-calculus or whatever you took prior to this class, solving a quadratic. You learned it at that point. We are going to complete the square just with a rational expression. Okay, so just with that rational expression. So if I take out the negative, I have x squared plus 8x plus 7. You always want to work with that positive leading coefficient. All right. Now, if you remember back to completing the square, when you complete the square, you are going to turn this x squared plus x using this b value here, and you're going to turn it into a perfect square trinomial. So I have this negative x squared, and then here I have this plus 8x. But what I'm really doing with this is I'm going to add blank to this, and if I add a number to it, I'm going to have to subtract that same number. All right? And the reason why is because if I add and subtract the exact same number, then I keep it equal. Plus or minus the same thing is still a 0. Do you see that? Okay, now I'm going to use this, and I'm going to have a squared term in there. That's completing the square. So I have x. This sign stays the same. I take my b value, which is 8. I divide that by 2, and then I square that, and that's the process of completing the square. This 4 goes in parentheses. This goes in that plus blank. So this one, if I add 16, I have to subtract it, right? But this piece right here is a perfect square trinomial, and that's why this 4 goes right here. Do you see it? That is completing the square. So if I complete the square, I have this perfect square trinomial right here. That's going to break down into this part. And now these two, I have negative 16 plus 7 is negative 9. But because I don't want to keep that negative sign out front, I'm going to distribute it, make that a negative, that a positive. So I can actually write this as 9 minus x plus 4 squared. And that is rewritten to go under my radical. Are you hanging in with me? I'm pausing just so that you can process that a little bit. Right? Complete the square. You want a leading coefficient to be positive. You're going to take this x squared plus the x term, even if it's a minus, it'd be minus. You're always, always, always going to add a number and subtract a number. The adding is going to go with this perfect square trinomial. So you can have this piece of it. Complete the square. We're squaring this to get that perfect square trinomial. Okay, then this is just the algebra. That's all we've done so far is algebra. Now my integral is I'm just rewriting this. I have dx over the square root now of 9 minus x plus 4 squared. So you have a quadratic. You cannot do a u sub. You can do completing the square. That's your defining characteristics. Now, I'm going to scoot this up. What's that pattern look like? Yeah, sine, right? Square that first term. Minus square the second term. It's okay that this is a squared right in there. If you want to do a u sub for this, you can. But again, right, look at what happens when I do a u sub. U would be x plus 4. du is dx. So why would we waste our time? Right? Think about this as a full unit and you don't have to do that u sub. I'm pushing you because it's Calc 2 and I'm pushing you to be efficient. If it helps you to do a u sub, so that is a u sub there instead of an x plus 4 in there, and it makes you feel better, that's fine. Now I'm going to push you hard so that you can go through here, and be more efficient. I'm not doing the u sub. So I know that this is sine, so a here is equal to 3. X in this instance is actually a full x plus 4. And this is sine. And remember, sine doesn't have that coefficient. So this is just going to be inverse sine of x over a. And that's our final answer, directly to it. All right. A lot of this chapter, we've learned lots of different algebraic manipulation techniques. That's what this section is all about. We're going to use a lot of these concepts moving forward with different parts of this chapter. Different sections are going to use these concepts. This is a lot of different concepts all in one. So make sure you're taking time and you're practicing this 8.1. Algebra, algebra, algebra. You can do it. Algebra is awesome. If you say it, then it's true, right?